Picture this. It's 2014, and a team of researchers does something that honestly sounds like it's straight out of a sci-fi movie. They connected two human brains over the internet and let them share a thought. No speaking, no writing, no physical cues whatsoever. This is the story of how digital telepathy became real.
It's a question we've all probably wondered about at some point. Is telepathy even possible? Communicating directly, mind to mind. It feels like a superpower, something from the comics. But what if it wasn't just a fantasy?
Because in that year, a landmark scientific paper came out that showed for the very first time that, with the right technology, direct brain-to-brain communication was actually possible. Okay, so let's get into the nuts and bolts of this thing. How on earth did they actually build a system that could take a thought from one person's head and send it to another, especially across thousands of miles? So, this is the big picture, the blueprint for the entire system. And yeah, I know, it looks a little technical, but trust me, it's actually pretty simple when you break it down. You've got the emitter on the left. That's the person sending the thought. And on the right, you have the receiver, the one getting the message. And that bit in the middle connecting them, that's just the internet. The whole challenge really comes down to one thing. How do you get a thought out of one brain and then into another? Let's start with the sending part.
So first things first, you've got to somehow grab a thought out of someone's head and translate it into a language a computer can actually read. And what's the universal language of computers? Yep, good old binary, just ones and zeros. The magic trick here is something called a brain-computer interface, or a BCI for short. Basically, the person sending the thought, the emitter, wore this special cap. And this cap could read their brain's electrical activity, their brain waves, using a method called EEG. The BCI's whole job was just to turn those brain signals into digital code. So, how did they do it? This is the really clever part. It wasn't about reading complex thoughts like, "What should I have for dinner?" No, they kept it super simple. They asked the emitter to just think about one of two things, moving their hands or moving their feet. See, those two thoughts create very different, very easy to recognize patterns in the brain. The EEG cap spots the pattern and the computer takes it from there.
And right here, you can see just how simple and elegant that code was. It's just a binary choice, right? Think about moving your hands. Boom, that's a 1. Think about moving your feet. That's a 0. And just like that, a conscious thought becomes a little piece of data, ready to be emailed anywhere on the planet. Okay, so we've got our thought converted into ones and zeros, and it's zipping across the internet. Awesome. But that's really only half the job, isn't it? How does the receiver, who's sitting in a totally different country, actually get the message? Well, this is where the second piece of the tech comes into play.
So remember the BCI? That gets information out of the brain. Well, to get information in, you need its counterpart, a computer brain interface, or CBI. The whole idea here was to take that binary code from the computer and deliver it straight to the receiver's brain so they could actually perceive something.
And to make this happen, the researchers used this really cool phenomenon called phosphenes. Now that sounds super scientific, but it's something you've probably experienced yourself. Just close your eyes and gently press on your eyelids. You see those little spots and flashes of light? Those are phosphenes, and it turns out you can create them artificially. And this is how they put it all together. The person on the receiving end was totally isolated. Eye mask, earplugs, the whole deal. A device aimed a magnetic pulse at the part of their brain that handles vision. And the code was simple. If the computer sent a 1, the pulse would fire, and the person would see a flash of light, a phosphene. If the computer sent a 0, nothing happened, no flash. So a flash of light meant 1, and no flash meant 0. The message was delivered. All right, the moment of truth. They've got the whole system built. They can get a thought out, turn it into code, send it across the world, and turn it back into a perception. But would it actually work? Could they send an entire word from one person to another, separated by an ocean? And this wasn't just in a lab next door. Look at this. The sender, the emitter, was in India. The receiver? All the way over in France. We're talking nearly 5,000 miles apart. The emitter started the process thinking hands for a 1, feet for a 0, sending that first message bit by bit across the globe. So, what was it? What was the very first word sent from one human brain to another, across an ocean, without any of the normal senses? It was the Spanish word for hello, hola.
And to make sure this wasn't just some crazy coincidence, they did it again. New person receiving the message. This time they sent ciao, the Italian greeting. And it worked. This was real. It was repeatable.
So you might be wondering, okay, but how well did it work? Was it messy? Get this. In that second experiment, the total error rate, from start to finish, brain, computer, internet, computer, back to brain, was just 4%. That's incredible. For a brand new technology, that is unbelievably accurate. Look, this experiment wasn't just some neat party trick. It fundamentally cracked open the door to a whole new way for us to connect. It really was the beginning of a brand new conversation about what communication could even be. So, the big question is what's next? Even the researchers who did the work knew they were onto something huge. They said, and I'm quoting here, "We anticipate that computers in the not-so-distant future will interact directly with the human brain in a fluent manner." They saw this as just the beginning.
And just think about what that means. The possibilities are, well, they're kind of staggering. We're not just talking about sending words. What about sending emotions? Or what if you could connect your brain to new sensors and, I don't know, see in infrared? You could even have real back-and-forth conversations between minds. Of course, this opens up a whole can of worms, ethically and socially, that we're going to have to figure out.
And that brings us to the final, and maybe the most important question of all. Our thoughts have always been private, right? Trapped inside our own heads until we choose to speak or write them down. But what happens when that's not true anymore? If we could truly connect our minds directly, what would we even want to say to each other?